So to this post now we are going to connect this clamp. Remember, we need to use the rod of the clamp. So I'll connect this clamp like this. We are more interested in using the rod of the clamp, this rod of the clamp here. So to the rod of the clamp we will put our string loop. And remember, it is through this string loop that we must put this weight, this ruler. Now we have to put it exactly as it is shown there, and you have to be wise enough when you are putting it such that you put it in a proper manner such that it will balance. So if I put it like this, now who is going to balance the other side? So for now I will leave it like this. On the other side, if we check out carefully, there is another string loop, a spring, and a mass hanger. So I will continue now with reading the instructions. Add the two 50-gram masses to the mass hanger to make a total mass of of 110 grams. So this is a 10-gram mass hanger already. So if I add this 50-gram mass and another 50-gram mass, then this becomes 110. So this 110, then suspend the mass M from the spring. So we are going to then put it from the other side and then suspend it. Then record the mass M. We already know, of course, that this mass M is 110. So still we follow instructions as they ask us. We record that 110. The distance between the strip, the string loop supporting the spring and the 50 centimeter mark on the row is B. The distance between the top of the loop spring and the bottom of the loop of the spring is X. I believe you can also see all the X on the diagram there. Adjust the position of the string loop supporting the spring until the row is horizontal. So we must balance this. It must be put at the 50 centimeter mark here, but who are we moving? We are moving this one until this balances. So as you can see, it is going this side, so I must move this again. I must move it until it balances. Sometimes we might never find the balance point. Here seems to be almost the balance point here. Let us see. Seems to be almost the balance point. Seems to be balanced. Seems to be balanced. So that's the balance point. So they then said the rule I think is almost approximately horizontal. In this practical, you can never achieve some of those things, like for example making the row very horizontal. You have to live at least with it being approximately horizontal, and they also say it approximately horizontal anyway, and in equilibrium. Measure and record X and what? And B. Remember, X is from the 50 centimeter mark to where this string loop is. So X for me is 27.7. Sorry, that's B. 27.7. And you must write the units. It is measured by a ruler, so it's 1 decimal place with unit centimeters. Then I must measure X again. X now is for the spring. I must make sure that I don't disturb the spring so that it doesn't start to oscillate. Okay, so that's approximately 8.8. 8.8 centimeters. So let's go to the next page. It says, repeat B with the different values of M until you have 6 sets of readings. Record M, X, and B. Include your values from B. So we must include our values from B. So I'll draw a small table here. We are supposed to record M, we are supposed to record X, we are supposed to record B. So what are we doing? We are changing the value of M. Here, originally, the first value of M was 110, and we saw that X for 110 is actually 8.8. Then we also saw that B for 110 is actually 27.7. So now we are going to change now. Remember, you're supposed to have repeat B with the different values of M until you have 6 sets of reading. We have already 1 set of reading, so we want to have 6 sets of readings. So first things first, I'll use all the masses that I'm given. I'll put them there so that we shall see what happens. and we'll find the balance point again. I will use all the marks that are given. So as you can see, it is tilting, so I must move this until it balances. It is 2, then tilting to the other side, move it a little bit, still tilting to the other side, move it a little bit again, a little bit. Okay. Okay, so as you can see, I'm failing to find the balance point. Now we have finally found it. Now, I could actually read directly from the meter rule, my meter rule. For example, from my meter rule, which has a clearer scale, if I don't want to use a ruler there, I can count that here it's approximately at 28.9, but here it's at 50. So 50 minus 28.9, that will give us 21.1. So that's 50 minus 28.9, that's 21.1. So that will be B. B is 21.1. But what is the total mass? Total mass is 110 plus the extra 10 gram masses. So the total mass is 140. So now I want to measure X so that we can find the value of X. So the value of X will be 10.3. So that's 10.3 there. Okay, so since we want 6 sets of readings, I will now remove the first mass here, the small mass which is on top there, and make it 130 now. So I'll try to balance again. You see it cannot balance again. So what do? I move it a little bit again. So still it's not balancing. It's almost balancing, but not yet. I'll move it a little bit. It tilts to the other side. Okay. So the balance point, if sometimes we don't want to waste time, if you cannot find it sometimes, it seems I'm almost finding it, but if you don't find it sometimes, you have to estimate where it tilts to the other side and where it tilts to the other side, and the midpoint of that, then that's your balance point. In this case, I think my midpoint of that is at 26.3. So from 50 to 26.3, that's 20.